Welcome to another deep dive. This time we're taking a closer look at a component that's absolutely essential to the quantum technology revolution, and that is cathodes.
Cathodes.
Yeah, we'll be exploring an essay by Jorgo H. Nephat titled, it's in German, Cathode, Essentiell für Fortschritte in der Quantentechnologie,
Okay.
which translates to cathode, essential for advances in quantum technology.
Yeah.
Now, you might be thinking of old TVs and radios when you hear the word cathode.
Yeah.
But trust me, cathodes are so much more than that. With the help of our expert, we're going to unpack how they're enabling groundbreaking advancements in quantum computing, communication, and even supersensitive sensors.
I think what's really fascinating is how Schnephat highlights the versatility of this seemingly simple component.
Right.
Like for centuries, we've harnessed the power of electrons emitted from cathodes, but now it's all about precision and control at the quantum level.
Yeah, okay, so let's start with the basics. Like, how do cathodes actually work? Can you give us like a simple rundown? Imagine you're explaining to someone who hasn't thought about physics since high school.
Okay, so imagine a material that under certain conditions releases electrons, almost like it's sweating them out.
Okay.
And those electrons form a beam that we can then manipulate.
Yep.
That's the essence of a cathode. There are different ways to get those electrons to break free, whether it's by heating the material, shining light on it, or applying a strong electric field.
So it's all about getting those electrons to jump ship.
Exactly.
Okay, so now let's connect this to the quantum world.
Right.
Schnephat's essay really dives deep into how cathodes are being used in quantum computers.
Yeah.
So what's the connection there?
Well, think of quantum computers as incredibly complex machines that operate on the principles of quantum mechanics.
Right.
Exploiting things like superposition and entanglement to perform calculations in ways that classical computers just can't. And to do that, we need to control quantum bits, or qubits, which are like the building blocks of these systems.
Right. So where do cathodes fit into all of this?
Well, one way is through superconducting qubits, which rely on superconductivity, a phenomenon where certain materials exhibit zero electrical resistance at extremely low temperatures.
Wow.
Cathodes can play a crucial role in controlling the flow of electrons in these superconductors with incredible precision.
Okay.
Helping to maintain those delicate quantum states that make these qubits so powerful.
Yeah, it sounds like it's all about maintaining that delicate balance, ensuring those quantum states don't collapse.
Exactly.
What are some of the challenges involved in achieving that level of precision?
Oh, it's a monumental task. You need to minimize energy loss, control those electrons with pinpoint accuracy, and ensure the environment is perfectly stable.
Right.
Even the tiniest vibration or temperature change can disrupt these sensitive systems.
Wow. It's amazing to think about the level of control required to harness these quantum phenomena.
Yeah.
Now, Schnephat's essay also touches on the role of cathodes in quantum communication.
Right.
Which sounds straight out of science fiction. What's the story there?
Think about it, unhackable communication channels that rely on the principles of quantum mechanics to ensure absolute security. Pretty amazing, right? Well, cathodes are essential for creating these secure quantum communication channels.
Okay, so how does that work? How do cathodes contribute to unhackable messages?
It's all about creating and controlling these things called coherent electron beams.
Okay.
Which are basically streams of electrons that are all in sync with each other, acting like a unified wave.
Okay.
These coherent electron beams can be used to manipulate and transmit quantum information in ways that are impossible to intercept or eavesdrop on without disrupting the delicate quantum states, essentially making the communication unhackable.
So it's like creating an unbreakable seal on the information being transmitted.
Exactly.
That's incredible. But how do you even create these coherent electron beams in the first place?
That's where cathodes come in. By carefully selecting materials and designing the cathodes with precise structures, we can generate these highly coherent electron beams with the specific properties needed for quantum communication.
So it's not just about any old cathode.
Right.
It's about designing them specifically for these quantum applications.
Exactly.
That's fascinating. Schnephat also mentions the importance of cathodes in precision measurement and sensors.
Yeah.
Can you tell us more about that? What kind of sensors are we talking about here?
Think of sensors that can detect things at the atomic level.
Wow.
For example, scanning tunneling microscopes, or STMs.
Okay.
Rely on cathodes to generate a beam of electrons that can feel the surface of a material with atomic precision.
So it's like having a tiny finger that can trace the outlines of individual atoms. That's incredible.
Yeah.
Are there other types of sensors that utilize cathodes in this way?
Absolutely. There's a whole world of quantum sensors that go beyond STMs.
Okay.
We're talking about sensors that can detect minute changes in magnetic fields, gravitational fields, and even the presence of individual molecules. These sensors have the potential to revolutionize fields like medicine navigation and environmental monitoring.
It's mind-boggling to think about the possibilities. But I imagine there must be some pretty significant challenges in developing these superpowered cathodes.
Oh, yeah, definitely.
What are some of the hurdles researchers are facing in this area?
Well, as we've discussed, it's all about precision and control at the quantum level.
Right.
We need to find materials that can emit electrons with the right properties and in a controlled manner.
And is there a particular type of material that's best suited for this?
There's no one-size-fits-all solution, unfortunately.
Yeah.
Different quantum applications require different types of cathodes with specific properties. For example, superconducting cathodes, which utilize materials that exhibit zero electrical resistance at extremely low temperatures, are highly sought after.
Yeah.
Because they minimize energy loss, which is crucial for maintaining those delicate quantum states.
So finding the right material is key.
Yeah.
What are some of the other challenges?
Creating those perfectly uniform nanostructures is incredibly complex.
Okay.
And even the tiniest imperfection can disrupt those delicate quantum states.
Yeah.
It's like trying to build a house of cards on a vibrating table.
Right. It sounds like an incredibly delicate balancing act.
It is.
What about controlling the emission of electrons? Is that a challenge as well?
Absolutely. We need to be able to control not just the number of electrons emitted, but also their energy and direction. Imagine trying to hit a bullseye on a target that's constantly moving and shrinking.
Wow. That sounds incredibly challenging. But despite all these hurdles, Schneepat seems to be optimistic about the future of cathode development in quantum technology.
He is.
What kind of breakthroughs could we see with further advancements in this field?
Well, imagine superconducting cathodes that are so stable and precise that they enable the creation of large-scale, fault-tolerant quantum computers, capable of solving problems that are currently intractable for even the most powerful supercomputers.
So quantum computers that can revolutionize fields like medicine materials, science, and artificial intelligence.
Yeah.
That's an incredible vision.
It is.
What about unbreakable encryption thanks to the role of cathodes in quantum communication? What are the possibilities there?
Oh, the implications for cybersecurity are enormous. Imagine a world where sensitive data, financial transactions, and even national secrets can be communicated with absolute security.
A truly unhackable world.
Exactly.
It's mind-boggling to think that cathodes could play a role in harnessing this bizarre quantum phenomenon for communication.
Yeah, it is.
So from unbreakable encryption to super-sensitive sensors and quantum computers that could change the world, it seems like cathodes are at the heart of it all.
They really are.
Who knew that this seemingly simple component would have such a profound impact on the future of technology?
It's amazing, isn't it?
It really is. And it's a testament to the incredible power of human ingenuity.
Yeah.
And our relentless pursuit of understanding and manipulating the universe at its most fundamental level.
Absolutely.
And as Jorgo Schneepat so eloquently illustrated sometimes, the most revolutionary technologies are built upon seemingly humble components, like the cathode.
I completely agree.
It's been a fascinating journey exploring the past, present, and future of cathodes, from their role in those old TVs to their potential to unlock the secrets of the quantum world.
It has.
Thank you for joining us on this deep dive. What about those super-sensitive sensors? Schneepat hints at sensors that can detect things we can't even fathom right now, all thanks to those super precise electron beams produced by cathodes.
Right.
What's the most exciting potential application in your mind?
Oh, wow. The possibilities are truly mind-boggling. For me, it's the potential for these sensors to revolutionize healthcare.
Okay.
Imagine a world where we can detect diseases at their earliest stages using sensors that can identify individual molecules associated with specific conditions.
Wow.
We could diagnose and treat diseases with unprecedented precision, leading to better outcomes and longer, healthier lives.
That would be a game changer. It sounds like we're on the cusp of a quantum revolution, and cathodes are playing a pivotal role in driving this revolution forward.
Yeah.
But as with any cutting-edge technology, there are bound to be challenges along the way.
Right.
What are the biggest hurdles we need to overcome to unlock the full potential of quantum cathodes?
Well, as we've discussed, material science is at the forefront.
Okay.
Creating cathodes with the precise properties needed for quantum applications is incredibly complex. For example, achieving perfect uniformity in nanostructures like carbon nanotubes and graphene is incredibly difficult.
Right. It's like trying to build a perfectly symmetrical skyscraper out of individual atoms.
Yeah,
The level of precision required is mind-boggling.
it is.
What about controlling defects in these materials? Isn't that a major challenge as well?
Absolutely. Even the tiniest imperfection can disrupt those delicate quantum states.
Yeah.
It's like trying to maintain perfect balance on a microscopic tightrope. We need to find ways to minimize these defects and ensure the stability of these quantum systems.
It sounds like a constant battle against imperfections at the atomic level.
It really is.
What other challenges are researchers grappling with?
Another major hurdle is achieving precise control over electron emission.
Okay.
In quantum applications, it's often necessary to emit single electrons on demand or create highly synchronized pulses of electrons.
Yeah.
Achieving this level of control requires an incredibly deep understanding of the quantum behavior of electrons at the cathode surface.
So it's like trying to choreograph a ballet of electrons, ensuring that each one moves with perfect timing and precision.
Yeah,
That sounds incredibly challenging.
It is. And it's not just about controlling the electrons themselves.
Right.
It's also about minimizing any external factors that could disrupt their delicate quantum states.
Okay.
Things like vibrations, temperature fluctuations, and stray electromagnetic fields can all wreak havoc on these sensitive systems.
So it's like creating a perfectly serene environment for those quantum electrons to do their dance free from any disturbances.
Exactly.
Sounds like an incredibly delicate balancing act. So are you optimistic about the future? Does Schneeppot leave us with a sense of hope for overcoming these challenges?
Absolutely. Despite these obstacles, Schneeppot's essay highlights the incredible progress that's been made in recent years.
Okay.
Researchers around the world are pushing the boundaries of materials, science, nanotechnology, and quantum engineering, searching for innovative solutions to these challenges.
That's encouraging. What are some of the most promising avenues of research? What breakthroughs could reshape this field in the coming years?
One exciting area of exploration is the development of new hybrid materials that combine the best properties of different types of cathodes.
Okay.
For instance, imagine a cathode that incorporates the high conductivity of graphene with the stability and energy efficiency of a superconductor.
That sounds like a recipe for a quantum cathode powerhouse.
Yeah.
What about advancements in electron traps? Could those lead to more powerful quantum computers?
There's tremendous potential there as well.
Okay.
Optimizing electron traps to create even more stable and controllable qubits for quantum computing could involve using new materials, refining the geometry of the traps, or even exploring entirely new trapping mechanisms.
It's fascinating to think about the possibilities. And what about the potential for revolutionizing quantum communication? Are there any breakthroughs on the horizon in that area?
One exciting avenue is the development of cathodes that can directly emit entangled electrons, which are essential for creating secure quantum communication channels.
Okay.
Imagine a world where sensitive data, financial transactions, and even national secrets can be communicated with absolute security, all thanks to cathodes.
A truly unhackable world.
Exactly.
It's mind-boggling to think that cathodes could play a role in harnessing this bizarre quantum phenomenon for communication. So from unbreakable encryption to super-sensitive sensors and quantum computers that could change the world, it seems like cathodes are at the heart of it all.
They really are at the heart of it all.
Who knew that this seemingly simple component would have such a profound impact on the future of technology?
It's a testament to the incredible power of human ingenuity and our relentless pursuit of understanding and manipulating the universe at its most fundamental level. And as Yurgo Schneeppot so eloquently illustrated, sometimes the most revolutionary technologies are built upon seemingly humble components like the cathode.
It's been a fascinating journey exploring the past, present, and future of cathodes, from their role in those old TVs to their potential to unlock the secrets of the quantum world.
It really has.
Thank you for joining us on this deep dive. Yeah, it's amazing to think about the journey of the cathode, from those early experiments with gas discharge tubes to the intricate world of quantum mechanics.
Yeah.
It's a testament to how scientific discoveries often build upon each other, leading to unexpected breakthroughs.
Right.
Who would have thought that something as seemingly simple as a cathode could hold the key to unlocking the potential of quantum technology?
I think it's a reminder that innovation often comes from unexpected places. Sometimes the most groundbreaking discoveries aren't about inventing something entirely new, but about finding new ways to utilize existing technologies.
Right.
And as Schneppat's essay highlights, the cathode is a prime example of this.
It's a great point. We often get caught up in the hype of the new and shiny.
Yeah,
But it's important to remember that progress is often built upon the foundations laid by those who came before us.
absolutely.
And it seems like the cathode, with its long and fascinating history, is poised to play an even greater role in shaping the future.
Absolutely. As we continue to explore the mysteries of the quantum world, I have no doubt that cathodes, in their ever-evolving forms, will continue to be at the forefront of discovery and innovation.
Well, you've certainly given me, and hopefully all of you listening, a lot to think about. It's been a fascinating journey exploring the world of cathodes, from their humble beginnings to their mind-blowing potential in quantum technology. A huge thank you to Jurgo Schneppet for his insightful essay that served as the basis for our deep dive today, and to our expert for guiding us through this complex and fascinating world. Until next time, keep exploring, keep questioning, and keep diving deep.